So let's take a look at what this would tell us if these were co-located PM2.5 monitors. So now it may be that having a difference of 50% between your two measurements is okay. It depends upon what you're measuring and what your goals are. You know, if all you're trying to tell if something is, empty or full or things like that, the exact values don't really matter. Sometimes if you need to gather a lot of data and your instruments are cheap, but you would prefer to spend your money on buying more instruments that have maybe a pretty bad precision, maybe a precision error of 50% is okay in that case. In the case of co-located PM2.5 measurements, though, it isn't. So what I would do in this case, if this were my site and I had precision results that look like this, say I was just beginning and I was taking every sampling day measurements, and I was starting out to try to figure out what the precision error is before I report the data. And so I've got my stuff going on here and I'm looking at this and I'm saying, whoa, I would say clearly something happened at this point in time. I would try to find out what happened, what was the difference, did anything change between the first point and the second and third and fourth. And I would definitely say at this point I don't think these things are measuring the same quantity. It looks like there's a difference between what they're actually measuring. So in terms of reporting your precision error, I would invalidate these measurements as long as I have enough for my completeness. But I could only do that if I really found some reason to say that there's something that happened here, or there's some problem with my measurement system that I haven't noticed. So clearly it seems pretty unlikely, really. Now we've got our ice is melted, but it's still pretty cold. Let's take a look if we really stir it around and press the reset button on these and keep our probes really side by side. What do we get? Let's make another, before anyone panics and invalidates data or recalibrates, it's always good to make another measurement. So we've got 11 degrees in A and 10 degrees in B. And if I kind of get these even closer together, it looks like they're going to go back both to 11 degrees. So I'm going to take apart my system here and try to figure out what happened. Well, what I noticed is the top of my platform is heightened a little bit, and somebody put a heating pad underneath my ice water bath. So when I had one of these probes down low, it wasn't measuring the same temperature of the water that's supposed to be homogeneous by stirring it as the one at the top. And if I had been more careful and followed my SOP, I would have stirred slowly during. I would have looked at the tips of the probes to make sure that they were near one another. So that's an illustration of how looking at precision error, especially precision error over time, and not just gathering the data, but really looking at it and saying, what does this data mean, can help you identify flaws in your system. So you can see that there's a lot of different components of precision error, and sometimes there's hidden ones too, like crazy people who put weird things in to just make the experiment come up with funny numbers.